All right, so to start off section 7.2, which is similarity transformations, we'll kind of go through a warm up together. It says a reading space is shown in the blueprint to the right. The dimensions are in centimeters, and the scale factor of the blueprint is 1/50th. What are the actual dimensions of the reading space? So, right, our blueprint. So, our blueprint, right, we have a length of 14 centimeters and a width 12 centimeters. All right, so we also have a proportion or a scale factor, right, from blueprint to actual is 1 to 50. Okay, so, right, we'll find the length and the width, right? So our actual length, right? So we have 14 from our blueprint centimeters over the length of our actual, which we don't know, so I'm going to leave as L. And that's equal to our proportion or a ratio or a scale factor of 1/50th. Now, right, we just cross multiply. So L times 1 is L. 50 times 14 is 700 centimeters. Therefore, our actual length is 700 centimeters. Now our width will be 12 over W is equal to 1/50th. Same thing, cross multiply. We get W equals 600 centimeters. So it was just a short warm up of solving proportions and using our scale factor. Now, the first example we'll look at is it says if line M is represented by x equals -3, what is the graph of the reflection of M over M and a dilation of 0.5 or 1/2, right? So remember when we have these composition problems, we do the second part first, okay? So remember, dilation first. Then we do our reflection over M. We can draw that reflection line of M. Right, here's our reflection line because it's x equals -3. Right, this is line M. Okay, but first we want to do our dilation of 1/2. So we need to multiply each coordinate by 0.5. So 0.5 times 2, 4, right, for A. B is 0.5 times -2, 8. And C is 0.5 times 0, 10. And then after the dilation, we get A prime is 1, 2 because it's half of 2 and half of 4. B prime is -1, 4. And C prime is 0, 5. Right, so we can draw it, right? 1, 2 is A prime. B prime is -1, 4. And C prime is 0, 5. Now, right, a reflection of M, meaning x equals -3. So, right, that means we're going the opposite distance from x equals -3 for each of those 3 points. Right, so we can see A is 4 to the right. So that means, so A prime is 4 to the right. That means A double prime is going to be 4 to the left of that line. Right, so 1, 2, 3, 4. So here's our A double prime. B prime is 2 to the right. Therefore, we go 1, 2 to the left for B double prime. C is 1, 2, 3 to the right. Therefore, 1, 2, 3 to the left for C double prime. And here is our final image. Okay. So we did a dilation to get the single primes, and then we got the double primes on doing a reflection over line M, right? So we went the opposite distance from this line M here. All right, now example 2 says what composition transformation maps this XYZ to JKL, right? So the first step we can do is get the same orientation of our final image or triangle JKL. So we want it to point in the same direction, right? Where J is on the top right, K is on the bottom right, and then L is on the top left, right? So what can we do to do that? Well, we can take this original image and rotate it 180 degrees, right? That will put us in somewhere in this quadrant here. So, right, let's do a rotation of 180 degrees of triangle XYZ. Right, 180 degrees should be XY, changes to negative X, negative Y. All right, so, right, our original X is at 2, 1. Z is at 4, 1. And Y is at 1, 4. Right. So what we need to do is take the opposite of all of them. Right. So X prime becomes, right, 2, 1 becomes negative 2, negative 1. So negative 2, negative 1 is X prime. Right. Y prime. Right. Y is 1, 4. So it becomes negative 1, negative 4. So negative 1, negative 4, Y prime. And then Z was 4, 1. So it becomes negative 4, negative 1. All right, so negative 1, 2, 3, 4. And here's Z prime. Okay. So right here is our image now. And we can see it's in the same orientation, right? It's facing the same way as our final image. Now the last piece, right, is to somehow map this new triangle, this prime triangle, to this JKL. Okay. So now what we have to do is we can see this this X prime, Y prime, Z prime is smaller than JKL. So let's find the dilation that's going to get our X prime, Y prime, Z prime to JKL. Right. So let's look at it. Let's look at the distance between that we can find right away. We have a straight line from X prime to Z prime. This distance is 2. Then we also have a straight line from J to L. This distance is 4. Well, if we want to find that ratio, right, we said JL is equal to 4, right? And then X prime Z prime is equal to 2. Therefore, our scale factor is equal to 2. All right, so you can check to see if it works, right? If we multiplied to get, right, we multiplied x prime right here. X prime is -2, -1. If we multiplied that by 2, we should get -4, -2, which is where j is. All right. Then the next one is k, or y prime to k. So -1, -4 times 2 should give us -2, -8, right? And that's exactly where k is. And then last one to check is z prime to L. So z prime is -4, -1. Multiplying both by 2, -8, -2, which is where L is. Therefore, right, we did a map. We first did a rotation of 180 around the origin, and then we did a dilation of 2. Remember, the first thing we do, we write second. Okay, so it's a composition. And then the second part is the first thing we did, which was a rotation of 180 about the origin. And then the second thing we did was a dilation of 2, a scale factor of 2, right? So that is our composition of transformations, mapping XYZ to JKL. The next thing we're going to do is quickly define similarity and similarity transformation. So similarity is just a relationship between two figures where all corresponding angles are congruent. I'm just going to abbreviate, right? And all corresponding sides are proportional, right? And that's from our last section. We knew that, right? All the angles were congruent and all the sides were proportional. Now we use a symbol, just this tilde right here, to represent similarity. So this is the similarity symbol. There's no line underneath it. I was just underlining it. It's just that little tilde. And then definition of similarity transformation is just composition of one or more rigid motions and a dilation. So one or more rigid motions and a dilation. So, right, our rigid motions are translations, reflections, and rotations, and then it's followed by a dilation, or dilation first. Right? It's just a composition of one or more rigid motions and a dilation. All right, let's look at a real-world example of using our scale factors. Right, so this is an artist wants to turn her sketch into a mural that covers a wall 15 feet high and 20 feet wide, but she doesn't want to distort any of the proportions in the sketch. Can she do it? Justify your answer. Okay, so the first thing we want to do is we're given in inches, right? So we need to change feet to inches. So we need to change the mural sketch from 15 feet high to 180 inches. Okay, the reason is because there's 12 inches in a foot. Okay, so right, our height. Oh, sorry. So it was 180 inches high. And then 20 times 12 is 240. So 240 inches wide. All right, we want to see if the proportion matches with 11 inches by 14 inches. Okay, so first we're going to compute the wall height to the sketch height, and then the wall length to the sketch length, right? And then once we find these ratios, they should be equivalent, right? And proportional. So the height, right? So the wall over the sketch, right? So the wall height was 180. The sketch was 11. Okay, if we reduce this, we should get approximately 16.36 if you put it in a calculator. Now the width, right? We should get the same thing. It should be about 16.36 if they are proportional. If not, then the proportions cannot stay the same. So again, wall over sketch. So the wall was 240, the sketch is 14. And then if we do 240 divided by 14, we should get approximately 17.14. Now they are not equal, therefore they are not proportionate. Therefore, no, right? She cannot do this. All right, so our last mathematical example is this one where it says, what are the coordinates of A prime, B prime, C prime, D prime after the similarity transformation? So again, do the dilation first, because in compositions, we do the second part first. Then we want to do a rotation of 90 degrees. Remember, 90-degree rotation, XY changes to negative YX. Okay, so we need to do the dilation to A, B, C, D, and then do a rotation of 90 degrees, right? It's about the origin, so all you have to worry about is this formula up here. Okay, so we'll take A, right, and multiply it by 0.5. So 0.5 times our A51. We also need to do 0.5 times B, 0.5 times C, and 0.5 times D. So we should get 2.5, 0.5 from half of 5 is 2.5, half of 1 is 0.5, half of negative 3 is negative 1.5, half of 4 is 2, half of 0 is 0, half of 2 is 1, and then half of 4 is 2, and half of 6 is 3. Now, right, we're going to need to use this formula. So, right, we need to change it to negative YX. Because we're doing a rotation of 90 degrees, right? This is the 90-degree rotation. This is the dilation of 0.5. So, last step, right? We get for A prime, we should get opposite of Y is negative 0.5 and X is 2.5. For B prime, opposite of Y is negative 2, and then X is negative 1.5. C prime, opposite of Y is negative 1, X is 0, and D prime, opposite of Y is negative 3, and X is 2. The last thing I want to just go over in this section is just a couple of things about similarity in circles. So things that you should remember is that all circles are similar to each other, right? They all keep the same shape, right? They're all circles, obviously. And then a similarity transformation will exist that maps a circle to another circle. So a similarity transformation will exist that maps a circle to another circle. So you won't really have to solve anything for circles, but you should remember these facts for certain things. If you have any questions on 7.2, let me know on Remind or Google Classroom.